All right, sketching our graphs at this stage, we're not interested in finding any x and y intercepts. We just really want to focus on the period of the graph and the amplitude of the graph, okay? So remember, when we're focusing on our graphs, our amplitude is that value out the front. That tells me how high the graph gets, yeah? So for the graph of sine x, maximum value of 1, lowest value of 1. All right, same for cos x, maximum value of 1, lowest value of 1. And the period, remember, is how long it takes to complete one cycle. Period is 2 pi. So in other words, for my sine graph, it takes a total of 2 pi to complete one cycle. Okay, and everything is symmetrical, which means that's half the distance, so that's only pi. That's half of that distance, which is pi on 2. That's half of that distance, which is 3 pi on 2. Okay, same for my cosine graph. All right, it takes a total of 2 pi units to complete one cycle. Okay, so there's my 2 pi. So there's pi at the halfway mark, pi on 2 halfway, 3 pi on 2 halfway. All right, the general rule, so I guess the key features, the graphs repeat themselves every 2 pi units. That's called the period, okay? And their periodic functions is because they repeat themselves, all right? Maximum, minimum, 1 to -1. The mean position is sometimes, it's a term that pops up every now and then. So the mean position is, I guess for our standard graph, it's where the graph reflects about. So it's that line there, that's the mean position. Okay, for our standard graph, it's our x-axis. So notice how, I guess, if you were to shade areas, everything is above and below is the same. So it's that section that splits everything in half. Okay, so that's my mean position, and the distance from the mean position out to the maximum or the minimum or the maximum, that's what our amplitude is. All right, now the general rule for our graphs, the period for a sine or cosine graph is 2 pi on n. The amplitude is just the size of the number out the front. There's no such thing as a negative amplitude for a graph. If we have a negative sign out the front, it means it's been reflected about the x-axis, doesn't it? All right. So in terms of sketching it, identify the key features and then we work on. So straight into it here. Let's have a look. So we've got an amplitude. Oops. I've got an amplitude of 2. The period is equal to 2 pi on n, which is 2 pi on 3. And the -1 there, it's been shifted down 1 unit. Okay, so what I tend to do is we sketch amplitude and period in one hit, and then we move the graph up and down as required. All right, so let's just see if we can get our graph a little bit bigger. Make it a bit easier to sketch. All right, so let's just start with one cycle. So it's a sine graph. The amplitude is 2, the period is 2 pi on 3. So 2 pi on 3 is there. So my graph goes up and down. So halfway is pi on 3. So it goes up, down, up in the space of 2 pi on 3. Okay? So with the -1 now, it's between 0 and 2 pi. So let's just keep sketching it. And there's 2 pi there. So that's just the graph of 2 sine 3x. Okay? So what if we go to a green? -1 shifts everything down 1 unit. So instead of going up to 2, we're down to 1 and down here at -3. And if you like, this mean value, which is our axis, okay, it's now at -1, which is there. So let's just, there's my axis for the mean value, which means that's where all my intercepts are now, moving down to there. And I reckon that sometimes just makes it a little bit easier to sketch. Maximum values at 1, minimum values at -1. Now, where the actual x-intercepts are is, I don't know, and we'll work them out later. Okay, so we just sketch through. Oop, that one was in the wrong spot. And we go through to 2 pi. So there's our graph of y equals 2 sine 3x minus 1. We should label endpoints whenever we do these graphs. So this endpoint here is going to be at the point 2 pi -1, and this endpoint there is at the point 0 -1. All right, so there's our standard graph. All right, let's do the same thing again for B. I might go straight into a little bit bigger to give me a little bit more room. All right, first things first, identify period. Period is equal to 2 pi on n, which is 2 pi on pi. So the period is 2. Amplitude is equal to 3. We have a reflection about the x, and the whole graph has been moved up 4 units. So again, amplitude and period in one hit, any reflections in the next. Okay, so between -1 and 2. So I'm going to start here, finish here, and the period is 2. It's a cos graph. So what normally happens, so it goes up to 3, down to -3. So it makes it a bit messy, my scale, I think. So my standard graph, so if that's 2, that's 3, isn't it? Oh, and that must be 3 there, -3 there. The period is 2, so that means that's the halfway mark. So we're going through there, and at about 3. Oops, and then we're going to come up here and stop there. Let's just get rid of that. Oh, what a whoops there. All right, so there's our first cycle of our cos graph. All right, so it took 2 units. So then if I come back the next way, we got like that, stopping at -1 and 1. So there's the graph in blue of cos pi x with a 3 at the front. Now what do we have to do? We have to flip things upside down because of that negative sign. So if you like, that -3 becomes +3. That stays there. This -3 comes down here. That stays there. That goes up there. That stays there. That comes down here. Yeah. And then we're going to shift everything up. So if you like, the graph is a little bit like this, where we've reflected everything about the x-axis. All right. And now we're going to shift everything up 4 units. So might as well make it, we'll go to yellow. So at -3, we come up to +1, which is there. At 3, we go up to 7, which is there. There's my, say in green, there's that average value of the function there again. Okay, so let's bring that up to 4, which is there. All right. So we cross at that point there. We cross at that point there. I cross at that point there. My maximum value up here at 7. My minimum value here at positive 1. That looks like I've got enough there. So we go down, through, up, down, through. Okay, so there's my graph. Again, endpoints, well, that's at the point 2 and 1. And this point up here is at the point -1, 7. So you can see straight away if we had to do a range, my range is from 1 to 7, and the domain is obviously from -1 to 2. All right, so just take it a step at a time. All right, there's no doubt. I think period and amplitude in one hit. I think to here, maybe is a tech free. Anything more involved, like the one underneath, probably going to be tech supported. Okay, especially if you have to find intercepts for things like this. So let's have a look at our graph here. So again, the first thing with all of our graphs, coefficient of x has to be 1. So 2 cos of, let's put a half out the front. That gives me x plus 2 between -pi and pi. So the difference here this time is amplitude 2 pi on n, which is a half. So the amplitude is 4 pi. Sorry. Let's just rub that out. The period is 4 pi. So let's stay with the amplitude, Mr. Gale. Amplitude is clearly 2. The period is 2 pi on n, which is 4 pi. That's better. What else happens? So that's that covered, the 2 there. And we're going to move 2 units to the left, aren't we? So we'll do that at the end. So again, cosine graph, amplitude is 2, period is 4 pi. So we're up here. Where's 4 pi? Shit, it's way over there. Well, this isn't going to work for us, is it? No, it might. It's got to do between -pi and pi. So if you like, there's 2 pi. So my graph should finish halfway to there. So there's pi. So the graph for the start of it is sort of like this. Yeah, because then we would continue on up to 4 pi. Halfway to pi, half of that is pi. And then we've got -pi here, which means our graph is just going to stop about there. All right, let's get rid of that other bit hanging off the side. So as funny as it looks or as weird as it looks, that's our graph between -pi and pi. Now, because we're going to move left and right, it's sometimes, in fact, we're going to move the whole thing to the left, aren't we? All right, so now we've got to move everything to the left 2 units. So this point here becomes here. That point there is at -pi. So this section here is that. So the point that was out here, so the graph would have gone up to here at 3 pi, and then it would have stopped over here at 4 pi. Okay, so that point there is now there. That intercept there has come back all the way to here. So my graph is going to look like something like that. All right, so my endpoints, -pi 0 and 2 pi, that's a 2, isn't it? 2 pi 2. All right, and the yellow line is the graph of the function. So a range of that one's going to be from -2 to +2, a range from -2 to 2, and our domain is being given as -pi to pi. Oh, hang on. -pi to pi, so why have I sketched it out to here? Okay? So, good little pickup. So, which means our range is going to change. We want to sketch the graph between -pi and pi. All right, so it's just that section. So let's fix up the range to be from -2 to 0. All right, so I guess the key point is, despite those little not reading question properly, let's do amplitude period first. Okay, get your graph in the correct form, right, and then do your shifts. And we'll have a look at it next time around in finding our intercepts.